as I was saying, for the and, we want both of the things to be true, otherwise it's false. So that's true, that's false, that's true, that's false. It's true, that's false, that's true, and that's true. Well, that worked out pretty well, all things considered. Let me double check it to make sure we got everything correct. That's right, that's right. All right, so now we need to figure out the arrow. When we figure out the arrow, what we're going to do is we're going to compare this column and this column. What we're looking for is any place where it's a T arrow F. That's a T arrow T, so that's going to be true. F arrow anything is true. T arrow T is true. T arrow F is false. Let's see. Yep. That's true. That's false. True and true. Since we have a mixture of true and false, this is going to be contingent. So these ones get very long very quickly. I'm not going to go all the way to K, but I will do J. And this will be the last one that I do, and I'll explain a little bit more about how to understand the key column. But K is 4 letters. I'm not about that life. We will not give you a 4-letter one on the exam for this type of truth table because that's evil. But let's do another 3-letter one because it's good practice. So letter J is P or Q arrow R, and all that's in parentheses. Double arrow, P arrow R, and Q arrow R. I need to extend this a little bit more. The thing to note here is, again, we have 3 letters on this side. So we're going to need to have 3 columns here. And we go in order, P, Q, R. Since we have 3 letters, the first column over here gets 4 T's and then 4 F's. Then we do 2 T's and 2 F's. And finally, we alternate T's and F's for our base column. Please, again, be sure that your base column is this column, and be sure to follow this order. Next, let's go ahead and actually identify what our main operator is. Remember, the main operator cannot be anything in parentheses, so can't be that, can't be that, can't be that, can't be that, can't be that one. So that means our main operator is going to be this double arrow out here, the biconditional. We know that we solve the main operator columns last, so let's go ahead and start solving stuff within the parentheses. Let's start with the inner parentheses on the left side, in this case, the wedge. What we're going to do is first, let's go ahead and actually slot in all the values again, because it's necessary. You'll notice that I'm bad at writing these in a row. This is why I need lined paper on my tablet. Now let's start starting for parentheses. For the disjunction over here to be true, it just needs to have at least one piece that's true, which means everything is going to be true except those last 2 rows. That's false, that's false. Then let's go ahead and solve these 2 over here. For an arrow to be true, it just can't be T arrow F. So everything is true except those 2 columns that I flagged as F's. Then over here, it's the same thing. Now we need to solve for the main operators within the parentheses, which is this arrow and that and. Before I do, let me clean this up a little bit. Whoops, deleted my and. Let's put the and back. Let's start with the arrow. To figure out the arrow, we're going to compare this column and solve for the arrow. T arrow T is true, T arrow F is false. T arrow T is true, T arrow F is false. T arrow T is true, T arrow F is false. F arrow T is true, F arrow F is true. Now let's solve for the AND. For an AND to be true, both pieces must be true. So T and T, true. F and F, nope. T and T, true. F and T, no. T and T, true. T and F, false. T and T, true. T and T, true. Now when we're solving for the main operator, we're going to be looking at this column and this column. And since it's a double arrow, a biconditional, what we need to see is that both of the pieces match in order for it to be true. So let's take a look. What we should find is T, T, true, F, F, true, T, T, true, F, F, true, T, T, true, F, F, true, T, T, true, T, T, true. So what we find is that we have all T's. Since we have all T's, this is a tautology or a tautologist. As I said, I'm not going to do letter K because letter K is extremely long and has 4 letters, but I do want to go back for a second and review why it is that we use this order over here. To do so, let's actually use an analogy. For folks that have taken a statistics class, a probability and induction class, or done combinatorics, permutations, combinations, and all that stuff in maybe a math class, this will sound a little bit familiar. But I'm going to use a different type of analogy. Let's say that I look into my closet and I see that I have the following. I have a shirt, and I have another shirt. That's a shirt. And let's say I have a pair of pants, another pair of pants. Assume that these things are the same brand and everything. Let's also say that I have different colors. So let's say that I have a blue shirt and I have a blue pair of pants. I also have a red shirt and a red pair of pants. How many outfit combinations do I have among these items? Well, I could have a blue pair of pants or a blue shirt and a blue pair of pants. I could have a blue shirt and a red pair of pants. I could have a red shirt and a red pair of pants. Or I could have a red shirt and a blue pair of pants. So here's shirts and there's pants. In other words, there are 4 possible combinations between the set of shirts that I have and the set of pants. There's 4 ways to get a combination of a shirt and a pant. When we think about what's going on up here, this pattern is doing exactly what we just did with the pants and the shirts. It's telling us what the different combinations of truth values are. So imagine the truth values are just like a color, where something either is a blue shirt or let's say it's not a blue shirt. And the P and the Q and the R, those are just an item of clothing. So if you're just talking about P's, then let's just say that you're just talking about pants. If you're talking about P's and you're talking about Q's, you're talking about pants and shirts. If you're talking about P's and Q's and R's, you're talking about shirts and pants and, I don't know, jackets or something. So as we get more complicated, we get more possible combinations of items. So that's why we follow this pattern. This pattern allows us to figure out all the possible combinations of true and false values that we could have among those set of items. If you were to try to figure this out on your own, you would have to sit there and ask, did I get every single possible combination of truth values? And that can take a long time. This is, again, like my 6-year teaching logic overall. And one of the things that I've seen in past exams is folks will sit there and try to figure out all on their lonesome all the possible combinations of truth values for however many letters we've given them. That takes a lot of time. It takes a lot of brain energy. And sometimes with such a short time for an exam, that can eat up a significant portion of the time that you have to actually take the exam and finish it. So that's why we furnished you this pattern. This pattern gives you all the possible combinations. And you'll also notice a different type of pattern within it as well. Within this row, we have one T that repeats. Within this one, it's 2 T's. Within this one, it's 4. If we add another row, it would be 8. And this just allows us, again, to capture all the possible combinations. So in this video, what I went over was how to figure out whether or not a specific proposition is overall a tautology, a contingency, or an inconsistency. For the next video, we're not really going to be talking about pants or shirts or even just about propositions. We're going to be talking about arguments and how to use a truth table to say whether or not an argument is valid or invalid.